Hey peeps, it's James Buckle from Engage Pixel here, and I'm really pissed off because they've cancelled the Expanse, god damn it. But anyway, check out this cool little dwarf fortressy AI I've been working on. It's an event-driven state transition AI. Does that sound awesome? Do you want to know how to code it? Well, you'll have to wait another month or so while I get the bugs out and write the tutorial for it. But don't fret, because I have this awesome tutorial on memory buffers instead. Now I know what you're thinking, that doesn't sound very cool. That's not a bunch of dwarves mining for gold and drinking beer and running away from goblins. Why don't I be watching some video about boring old memory buffers? Is this a bait and switch? Is this a bait and switch? This is totally a bait and switch. Thing is, whatever game you're making, you're going to want to let your players save their game state and then load it back up again later. That means you need to know how to write your data into a buffer and then get it back out again. In this set of videos, I'm going to cover everything you need to know to load and save your game data using buffers. In the first video, I'm going to show you how to do the basics of saving and loading a single set of data. In the second video, I'll show you how to loop through a list of data sets and combine them into a single file. In video 3, we will amend data to the end of the file. In video 4, we will overwrite entries in the middle of a file. In video 5, we're going to add a header to the beginning of a file, and then the last video I'll show you how to create a read-only object and then access individual entries on demand. And if all of that doesn't put you to sleep, then you get a nerd medal for being an awesome code nerd. So what's a buffer? Well, basically buffers are pieces of memory that are streams of bytes. Essentially just one long queue of bytes that goes on for a very, very long way. You read and write your data into buffers, and then you use the save and load buffer functions to write them onto the hard disk. I'm going to show you how to use buffers, starting by simply writing 4 pieces of information to a buffer, saving it to the hard disk, then loading it back up again. So the first thing I'm going to do is create a new object. I'm going to call that obj file with a capital F. There we go, obj file. And I'm going to create 2 scripts. One will be called save file, and the other will be called load file. There we go. Now we're going to go to the default room here, and I'm going to change the size to make it, because it doesn't need to be big for what we're doing, so I'll just make it 640 by 360, little diddy room, and then I'm going to drag obj file in and just kind of put it there, just about 64 in, and that's all we need to do with that room. So we're going to add a create event. And into this we're going to create a DS map. We're going to call it file data. And this is going to be a little map that just stores the data that we're going to be using. I'm going to create a bunch of dummy data for test purposes. Normally you wouldn't manually enter a whole load of data like this. You'd just put it in a file and then have the file loading. But because we haven't done file loading and stuff yet, I'm going to manually put them in. I'm going to create a region called hash region. Let's try hash region names. End region. Going to create a array called first name. And I'm going to put first name in. Let's go with John. Copy that. Change it to entry 1. And let's go with Jane. And then, using a little bit of video trickery, I'm going to click my fingers and the rest of the data is going to magically appear. Ta-da! You can put whatever first names you like into this array, and you can put as many names as you like into the array. Just go to town. Then we're going to do this for second names. So we're going to say second name 0 equals Smith. It's a nice boring first name. And then if we've had Smith, we might as well have Jones to go along with it. And then using computer wizardry, I'm magically going to make the rest of the second names appear. Ta-da! It's like I'm a magician or something. So again, you can put whatever second names you like in there. And as many as you like. I'm going to close that region off. And I'm going to make a second region called Moths, apparently. Let's try putting an M in there. There we go. Months. Hash end region. There we go. And this time I'm going to create a great big array called month that will be full of the strings for all the months in the year. Abracazam! Haha! Check that out. So now we have that. That's all we need to do for the create event. Now we're going to come back over here and we're going to add the key pressed space event. Now within this we're going to create the data for a new person and then add it into the map. So we're going to clear out the current contents by saying ds map clear file data. Then we're going to start with ds map add file data, and we're going to add a key for time, and we're going to use the current time variable, and we're just going to log when the person was added. I'm then going to say var f equals I random, and we want to randomly pick one of the names from the first and second name list. So we need to say array length 1D and first name. So that'll give us a random number between 0 and the number of entries that are in the... That needs to be -1, doesn't it? Yeah, I random what's it name -1 because the length will be 10 as I have 10 names. As I have 10 names, the length will be 10 and I need a maximum number of 9. So you need to put in array length, name of the array -1. And as a quick shortcut, you can copy this, change it to second name, and at the start make that an S. So we now have a random number to index both the first and second names in the array with. So we're going to say var name equals first name, put a space there to make it nice and neat, first name F plus a space, so you want to do 2 brackets with a space, 2 quotations with a space between them, plus second name S. So that will now give us a full name, and we can then add that name into the data structure, the file data map, and we'll use the key of name. So we go ds map add file data comma name, that's not how you spell name, underscore name, bloop. So we've now added name. We also want to add their age, so let's say var a equals I random. Let's try that again, I random, and let's say we only want adults within a certain range, so let's say from 18 to 64. Let's go with retirement age, 18 to 65. We then add this to the map, ds map add file data, comma, we're going to use the key of age, and we will add the value A. Now we're going to need to pick a month for the birth month, and once again we're going to go var m equals I random array length 1d month. So we now have a month minus 1. So we now have a random number between 0 and 11, which will give us a month to add to ds map. Add file data. We will use the key of month. My keyboard is playing silly buggers again. And we're adding, oh hang on, month m. So we use m to grab a string from the month array and we put it in there. And that's it, we've pressed space, we've now created a person's data. Their name, their age, their birth month, and the time at which they were added into this, that their entry was created. So now we want to actually see what that looks like, so we're going to need to draw it on the screen. So add a draw event. So now I'm going to add the, draw the contents of the file data ds map onto the screen. Now normally what you want to do is actually initialize the data into some variables and do it once. But not quite going to do that right now. I'm going to do that in the next video or so. Right now I'm going to do something that's slightly fudgy and I'm just going to actually just read it directly from the data structure in the draw event. So I'll say draw text xy ds map find value file data, comma, name is not how you spell name. And now we're going to copy that and paste it 4 times. And we're going to increase the y each time, so it draws each line a line apart. So we'll do plus 14, plus 48, plus 42, plus 28, plus 42. We're going to change this one to age, this one to month, this one to time. I'm also going to do is actually here I'm going to say age colon space close quotes plus string open bracket go at the end close the brackets, and on this one we're going to say born colon close quotes plus string open bracket go at the end close the bracket, and on this one we'll do entry added colon space close quotes plus string open brackets go at the end close the brackets. There we go. See, what this will be doing is in each draw event it's going to open the ds map file data and read out each bit of data and then be like blunk, there you go. Which you normally wouldn't want to do, you want to initialize this somewhere. But for this video, which has been long enough already, I'm just going to be like, boomf, do it like this way. It's a bit of a fudge, and I'm going to fix it later. So now we're going to have to save and load the file. For that, I'm going to say, let's add key press F1. Down here in the function keys, there we go, key press F1. And what we'll do here is we're going to I want to put all of this data into a single file, and we're going to save or load this file based on whether I press key F1 or whether I have the shift held down for F when I press F1. So I'll say if keyboard check VK shift, so if that, else something else. So if shift is held down, we want to save it. So I'm going to say save file, execute this save file script. Otherwise, I'm going to want to load the file. Now I'm also going to pass the file name as a parameter to this script. So we'll call this file 1 and also this file 1. Now you'll see a couple of errors there, and that's because at the moment I haven't actually put the code in for these arguments, so expecting no arguments at all and getting 1. So let's go ahead and put some arguments in by opening the save file, middle clicking on save file, and it'll open it up for you. And we're going to save the file by writing this data into a buffer, then saving the buffer. The way this works is that you create a buffer which is a stream of bytes. Each byte is numbered beginning with 0. Then you write each piece of data into it. Internally, Gamemaker has a pointer that points to the current position of the buffer that we're writing to or reading from. Each datum is then written at the current position, and once written, the position pointer is advanced. So if you start with an empty buffer like this, it'll be pointing at byte 0. We then write a piece of data like this, and it will go into the first byte. Ding! And the right position is advanced. Some pieces of data will be more than 1 byte in size, there might be 2 bytes, in which case the read position gets moved 2 along. And then each time a new piece of data is added, the right position moves. Essentially, this produces a queue of information. And all you have to then do is go back to the beginning of this queue and read it out. And as long as you read the data back out in the same way that you wrote the data to begin with, it all gets positioned back in the correct place. So when we go to the first position, and if we say, okay, read this first value into the position, it's a variable that I wrote first time, it'll position it back where it came from, advance the read buffer, and then when you read the next thing and you say I want to read this 2 byte piece of information, it should all get read back into the correct variables in the same order that you wrote it. And then all your data will be in the same place it started, and it will be neat and tidy. So let's write the actual code that does this. So we will say save the data. First thing you need to do is set up the name of the file that we want to work with. So we'll do a local variable called file, and that will be argument 0. Need an equals there. Argument 0 plus open quotes semicolon, and in there we're going to put dot buff. So this will be saving whatever arguments passed, which will be, in this case, going to be 1, so it will save a file called 1.buff. We're then going to create a writes buffer to put our data into, and we're going to call that far write buffer equals buffer create. So we'll create our buffer. Now for the size, you want to take a kind of a, if you're dealing with a fixed amount of data and you know the precise size it's going to be, you can specify the size. But in this case, because we're dealing with strings, we don't know the exact size. I'm going to start with a size of 128 bytes, which for the most part, if I remember my Windows correctly, it doesn't actually really handle file, well, it kind of ignores, it treats any file below 1K in size as being 1K in size. So it doesn't really make a difference. I could probably just put 1024 in there. But because I'm pretty confident that the size of the data is going to be less than 128. I'm going to start there. Now the next thing we need is the type of buffer, because if this was just fixed numbers, then at a fixed size of data, then you could use buffer fixed and you'd be fine. But because it's got strings, and strings could be any length, we're going to go with a buffer grow, if I can spell buffer correctly. So this will then grow the buffer. If it needs to, it will just make the buffer longer. Now, I don't know exactly what's going under the hood with buffer grow, but what I suspect, because is that it's doing something the same way an array is. Essentially, you'll say, okay, here's a, if you create this buffer at 1 to 8 bytes, if it exceeds 1 to 8 bytes, what it will likely do is then create a buffer that's then bigger by either 50% or twice the size, something like that, create a new buffer, copy the old buffer into that buffer, and then carry on working with the new buffer, which will be a much larger buffer. That's how arrays are handled. You create an array and you give it 10 entries. Then if you go over that 10 entries, it will, under the hood, what it actually does is give you 20 entries. And then once you go over the 20 entries under the hood, it gives you 40 entries, even though you haven't asked for it. Which is why when you use an array, it's generally better to create the array and assign the maximum variable, because then it's saying, like, actually I'm going to be dealing with an array of X size, and then any time you expand it, it's already there and doesn't take that little extra overhead. So using a buffer grow probably has a tiny little overhead with it, but because in Gamemaker you don't really have to worry about that sort of stuff, then we're going to go ahead and just use the buffer grow and take whatever the hit is. Now, alignment is going to depend on what kind of data you're using. If all your data is of the same type, then you can specify an alignment based on the size of the bytes you're dealing with. Because we're mixing data in this, and I'm going to have numbers and strings and so forth, we have to use a byte size of 1, or a byte alignment of 1. So having done this, we're now going to create our actual data that we write and start writing it. So we're going to say var time equals ds map find value, and we want to look in file data for the key of time. So having got the time, we're now going to write it into the buffer by saying buffer write, specify the write buffer. So we're pointing to the write buffer. Now we need to tell it the what type of data we're writing here. Now, because it's a number, you have a whole load of different ones to choose from. And what I'm going to use is a buffer u32. What that means is it's an integer, it's unsigned, and it's 32-bit. This means that this value that is being written can have because it's unsigned, it starts at 0. If it's signed, it goes from, you basically offsets it, and it but because it's unsigned, it can go from 0 to 65,000 and something. If it was signed, then it gets offset by 50%, so you have this kind of minus 32 to plus 32 or 33 or something like that. So you need to, when you write your buffer, you need to know how big your number's going to be and what kind of number it's going to be, to know how much room you need to leave it. And for the most part, I think, because we're not going to be running this for ages to get a big enough number to be too big for this buffer, we can specify a buffer for an unsigned 32-bit integer, so buffer u32. And then we tell it what date we need to write, which is the time. Next, we're going to grab the name, so var name equals ds map find value, and once again it's file data, and this time we need the key of name, and then we're going to write this to the buffer. And this will automatically be written into the next byte slot after the previous piece of data. The type here is buffer string, which will, there's buffer string, there's buffer text. Buffer string will be, it's a byte for each character, and then you have a null terminating character at the end, which a buffer string doesn't have, so which a buffer text doesn't have. I'm using buffer string here. And then we write name. Now, what will have happened here is that when the write buffer was created, the sort of the read-write head, as it were, is pointing at byte 0. When the time was written to the buffer, because a U32 is 2 bytes in size, it would have written the data into byte 0 and byte 1, and now the write head is pointing at byte 2. And then, depending on how long the name is and how many bytes in length this string you're writing is, this will now move the write head to the next byte afterwards. So now we're going to write age into the buffer, and age is ds map find value file data, comma, and the key of age. So we've grabbed our age out of the data structure map that we were using, and we're going to write it with buffer write buffer, and this time I'm going to specify a U8. Now this is an unsigned 8-bit integer, which means it takes up a single byte in the buffer stream, and because it's unsigned, it goes from 0 to 255. Now, because age can only be between 18 and 64, that sits within that, so I need to take up 1 byte in the stream to actually store this piece of data. It's only 1 byte in size, and it would be a waste to use a U32 or a U16. Or I've just realised a U32 is a number that goes from like 0 to several million or something. It's a U16 that goes from 0 to 65,000 and something. Yeah, U8 goes from 0 to 255, a U16 is 0 to 65,000, and a U32 is 0 to ridiculous. Yeah, and because we don't know what the value for time is going to be, that'll sit in a U32, which is 4 bytes in length. So yeah, in U8 we store age. So we've now written age to the buffer. That's advanced the write head one more spot. And then we're going to write the last piece of information, which will be the month. So we're going to grab month equals ds map find value file data, comma, month. So we've grabbed the string for the month of their birth, and we're going to write that again with buffer write buffer, and once again it will be a buffer string, and we write month. Then we have to say buffer save write buffer and specify that we're saving it to the file that we set up earlier. Now that we've written the buffer to the file, we don't need to keep that memory tangled up anymore. We can free it by going buffer delete write buffer. Now we need to load the data by loading a file into a buffer and then reading the data out of the buffer back into a DS map data structure. So if we go over here and middle click on load file, it'll open it in this little window for us. If you don't have a middle mouse to middle click, you can always left click, drag and drop it in here. So we're going to say load data through, that's not how you spell through, let's try that again, through buffer. So we're going to load the file into a buffer and then read the data out of the buffer back into a data structure where we will store it. So the first thing we need to do is set up the file name. So var file equals argument 0 plus dot buff. So that's the same line we opened the previous script with, same file name. Now, very important thing you have to do first whenever you try and load a file is you have to check that the file exists. If you try and load a file or access a file that doesn't exist, Gamemaker throws an exception and your game will crash, and that'll suck. So you need to actually check that the file exists first. So we say if file exists file, and then we're going to actually follow up by saying else, and we'll put a show debug message in here, and you can put whatever you like. I'm going to go done goofed, file can't be found, exclamation, 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 hashtag, exclamation. So assuming that the file was created correctly, saved correctly, and is now being loaded, we then read the buffer into, or we read the file into a buffer with buffer load. So we go var read buffer equals buffer load file. So now the read buffer variable that contains the nice long stream of bits or bytes that is our data. So now we have to actually use buffer read to read it out of this buffer into our variables, and we need to make sure we do that in the same order that we did it here in save file. So as long as we read it in the same order we wrote it, everything will go back in the same place. Think of it kind of like a mirror. As long as it gets projected on the wall and bounce back, and it'll all fit snugly in the right place where it's supposed to be. So we'll start with var time, as that's first, and that is buffer read buffer, and we need to tell it what type of data it wants to read. And if we look, when we wrote time into the buffer, we wrote it as a U32, so we need to read it out as a U32, buffer U32. So this basically tells the read function how many bytes to read out and put in and make a number out of. So that's going to read 4 bytes that comprise the U32. So we close the bracket there. We then put this into the DS map, and we say so a DS map replace file data key of time, and we're replacing it with the variable time. Now we're going to do the same for name. So buffer read buffer, and specify that it's a buffer string. So it will now read the bytes continuously until it hits a string, and until it hits the null terminating character, and then it goes, oh, that's the end of the string, so I'll stop there. And then we write that into the DS map with DS map replace file data, comma, name, key of name, comma, name. We do the same again for age. For age equals buffer read buffer. That does not say buffer read. That says buffer read. And then we specify that this was a buffer U8. We then DS map replace file data key of age with the variable age. Go. And lastly, we do this for month. So we make month equal buffer read buffer, and it's a buffer string. So we read a string out, and we DS map, it's not how you spell map, replace the file data key of month with the variable of month. Ding! So now, having saved it all to a buffer and saved it onto the hard disk as file, we now read it back out in the same order and put it back into this DSMap data structure. So now if we go back over here, I'm going to duplicate the key press F1 event with a key pressed F2, and I'm going to change that to say 2 and that to say 2. So now if I press F1 with or without shift, I can save or load file 1 and if I press F2 I can save and load file 2. And just for fun, I'm going to repeat this with the function keys, so key pressed function key F3, and we'll add a fourth just for shits and giggles. Function key F4, and that's 4 and 4. So now, if I save it and run it, fingers crossed. Okay, there we are. It's up and running. At the moment it says everything is undefined. That's because no data has been created yet. So if we press space, let's see who we get. Well, I've got Tim Burke, age 52, born in February. Depending on your random number generator, you might also have Tim Burke, you might have someone else. If you hold down shift and press F1, it doesn't look like anything's happened, but it has in fact just saved the file. And if you press space, we now get Jane Smith, age 28, born in March. And if we hold shift and press F2, she gets saved into file2.buf. Now if we press F1, hey look, Tim Burke's back. Let's press space again. We get Kate Jones, age 50, born in August. Hold shift, press F3, press F2, we're back on Jane Smith. Press F1, we're back on Tim Burke. Press F3, we're back on Kate Jones. Press F1, we're back on Tim Burke. So there you go, that's the basics of how to save a simple set of data by putting it in a buffer and saving that buffer as a file. And then of course loading it back up again. Now in the next video I'm going to show you how to have several data sets in a list and how to loop through that list and save each data set one at a time. Hopefully the video will be appearing in the top right corner of your screen, and you just click on that and I will see you in like 2 seconds.